Okay, so this is a question from this morning. I changed the values, and you're gonna see here that I changed it to 3Vx and the resistor values, just to give you an idea on how to do it. And it's the harder version of this, so you could have put here, instead of 1 milliamp, you could have put 1 volt and do a nodal analysis on here. And the thing in this morning's circuit that was so confusing is that the Vx shown there is minus Vx and plus Vx. I thought this was something we did in early homework assignments, but obviously I'm mistaken. So this is what it should show in your circuit. And here I'm showing you a 1 milliamp power supply that I added. And you see that there are no other power supplies. And the question is, what's the Thevenin or Norton resistance? And we're going to use mesh analysis. I saw a couple people getting stuck in mesh analysis, so this is a quick review. And I wrote here, I'm not sure we need to worry about math actually. I'm sure I made some mistake here, but the IB is minus 1 milliamp, and we don't write KVL for it, so we're done. But there are 2 KVLs, one for IA, one for IC. Except when you write these 2 KVLs, you get a third variable, which is Vx. And Vx I can write as a function of these 2 currents here. So if I do Ohm's law on Vx, it says Vx is 1K times the current through the 1K in this direction here, which is IB minus IC. But I already know that IB is minus 1 milliamp, so I'm multiplying it here 1K by 1 milliamp and getting minus 1. It's actually multiplied by minus 1. So this is my equation for Vx. I use this equation to substitute here so that I still have these 2 here. The black and the green are my IA and IC KVLs, but now with Vx substituted here. So I use another substitution. I write IA as a function of IC, and I end up with an equation that's only a function of IC. The reason I'm so interested in IC is that what is it that I'm looking for? I am looking for this voltage here, V whatever. I'm not sure V whatever, VW. This V whatever is going to be the voltage that I'm plugging in for that resistance. This resistance here, RTH, will be, I don't even know where to write, but RTH, the Thevenin resistance will be that VW divided by 1 milliamp, or you can say it's going to be 1,000, 1K times VW. So the question is, how do I find VW? I found IC. Hopefully my math is correct. I don't know if it is, but let's assume you find something like this. IC is minus 0.25 milliamps. And because I found IC, now I find Vx. Because I had written here, Vx is that Ohm's law there. Once you find Vx, actually I don't even know if I need Vx. Oh yeah, I need Vx. Because here's 3Vx. So let's say Vx is minus 0.75. 3Vx will be minus 2.25, I think, right? Minus 2.25. So here, this voltage here is Vt is minus 2.25 volts. And therefore, now I can sort of find VW by using Ohm's law again. So you see this 10 kilo ohm resistor here is exactly between the minus 2.2 and VW. So I'm gonna write this Ohm's law, assuming that IC is going here. So hopefully you see that the mesh current is going to the right. So I'm gonna say 10K times IC is VT minus VW. And now I have VT, I have IC, and I just need VW. So VW is VT minus 10K IC. Minus, I think this is going to be 2.5 maybe? Actually, I don't know. Yeah, 2.5. So it's going to be 0.25 volts. And now I can use the RTH, which is going to be VW times 1K, which is going to be 250 ohms. So this is because it's divided by 1 milliamps, right? So it's 0.25 divided by 1 milli. So this is my Thevenin equivalent, or my Norton equivalent. I hope this helps. I know the math is different than what you have to do, but it's the same circuit, so you should find something similar. I mean, not similar values, but that is the method that I find okay for 1 milliamp. If you do 1 volt, I suggest use nodal analysis, and you should get the same result. I hope this helps for Wednesday.